that is also trying to explore how best we can get out of scientific knowledge the best technologies that can serve people and planet. And this is at the center of the UN Climate Change Global Innovation Hub activity and vision. So without further ado, I will give the floor to our moderator, who will moderate the session. Thank you.
Thank you, Massamba, and please have a seat with us today. It's a big pleasure and honor for me to be here. We also have two speakers that are joining us from abroad. So you're on screen now. Welcome to you, Wendy and Alexandre from Switzerland. It's my big pleasure to welcome you here to this event today on this panel that we call Mobilizing Anticipatory Science for Disruptive Climate Action. My name is Martin Müller. I work at GESDA, the Geneva Science and Diplomacy Anticipator. A quick word about that in a minute. I am the Executive Director for Science Anticipation at GESDA. So before I introduce the panel for our conversation today, let me briefly introduce GESDA, the organization I work for. Well, GESDA is a young foundation that has been established 3 years ago in Geneva, with initial funding from the Swiss federal government and the canton of Geneva, and it basically follows two observations. The first one, I think we heard that today as well, that we are witnessing a period, an era of unprecedented acceleration of science and technology, and this acceleration has huge consequences about us as humans, the way we live together, but also our relationship to our planet. But we also have seen that multilateralism is in difficulties to address, on the one hand, the changes we see from science and technology, but also to tackle the global challenges such as climate change. What we want to do at GESDA with our partners, and Massamba mentioned the Global Innovation Hubs as one of those, is how can we address these challenges? Well, we do it in two ways. First, we anticipate what's happening in science and technology in the labs worldwide. And then we try to feed that into joint discussion between science and diplomacy in Geneva to develop the solutions that we will need to address some of those challenges. I was very happy this morning to attend a panel together with Jeffrey Sachs, Thioye, but also the Sustainable Network of Sustainable Solutions, where this idea of that we need to scout the science that we have on the horizon, to accelerate discussion between science and governance, to find common solutions was very much at the core of what they do. So I'm really happy that this is also on the agenda today. Now the panel today, I think we're very happy to have very distinguished panelists with us today. We'll address two main questions. On the one hand, how can we mobilize anticipatory science and technology for disruptive actions to respond to the climate emergency? And on the other hand, if we can anticipate the science, how can we build the coalitions of actors that we would need to accelerate the deployment of innovative solutions? Before starting the discussion, I would like to just quickly introduce the panelists that we have with us today. We have Professor Thelma Krug, who is the Vice Chair of the IPCC, the International Climate Change, and I learned today that this is 20 years that you have been working with IPCC, really trying to bring the message about science, what's happening in science, into the discussions with policymakers on climate change. You are Brazilian, so you come from Brazil, and very happy and honored to have you here today. We also have Wendy Queen. Professor Wendy Queen is a professor of chemistry. She works on new materials for decarbonization. She works at EPFL, the Swiss Political Federal School in Lausanne, and she has been engaged in GESDA as a scientific moderator, anticipating the new technology that we have in the pipeline for decarbonization. Then also on the screen we have Ambassador Alexandre Fasel, who is the first Swiss permanent representative, or special representative for science diplomacy. So this shows as well, how important it is for Switzerland as a country to bring together the world of science with the world of diplomacy, to craft the solutions that we need to address the challenges of tomorrow. Before being the Swiss special representative, Alexandre was, among others, the ambassador of Switzerland to the United Kingdom and permanent representative for Switzerland in the UN in Geneva, among others. As you can see, we have quite a good set and mix of panelists today, between the world of science and policy, between the world of science and diplomacy, global governance, but also at the level of the global innovation hubs, with the actors on the ground that brings the coalitions together to bring the solutions we will need for decarbonization. Now, the way I would like to run this panel is to give to each of the panelists here 3 to 5 minutes for an input statement before we enter in joint discussions. And I will also call with you to react, to ask questions, so that we can have a dynamic discussion before the session ends. To kickstart, I would like to start with you, Thelma, as Vice Chair of the IPCC. I think you have been involved in discussions about climate change since 20 years already, from the science perspective, we heard. But also you are bringing the perspective of science to the policymakers, to the diplomats around the world. My first question to you is, what are the lessons learned that you see in balancing the urgency to act now with the necessity to anticipate also what's happening on the horizon?
Okay, thanks. It's okay? Working? Is it working? Yes, you can hear me? Yeah, perfect now. Thank you. Yeah, thanks, Martin, for the question, and thank you for moderating, and thanks also to GESDA for inviting me to be here. And also thanks for saying that I'm with the IPCC for 20 years. So for those of you that do not know exactly what the Intergovernmental Panel on Climate Change is, it is a panel of governments, obviously, with 195 member governments, and that assess the literature all over the world on the specific themes related to climate change. So that includes the physical basis of climate change, adaptation, impacts, and vulnerability, and also coming to, I would say, to the solutions space of the IPCC. We would be talking about the report on mitigation. And by mitigation, IPCC means efforts to reduce emissions of greenhouse gases, and also means to enhance the sinks of, in particular, CO2, but we are now expanding to say also greenhouse gases, especially methane. So we don't do research, but authors do all this assessment. Now, interestingly enough, Martin, through these 20 years with the IPCC, I see a quick evolution, especially in the solutions space. So IPCC says that today we have enough options in place to reduce by half emissions in 2030 relative to 2019. Well, but that's not, simple. It seems, well, the technology is in place, evolves rapidly, but at the same time faces other barriers. For instance, institutional barriers, also technology barriers, I would say, social, cultural barriers, geophysical barriers. So you have barriers, financial barriers. I was almost forgetting that. So nothing comes really quick. But let me say, so when the authors are doing all this assessment, they reflect in the report that those technologies are coming into play. So they are being investigated, not necessarily being mature enough. So IPCC has what we call a specific language that indicates to government how mature, how confident are you on certain aspects of the implementation of that technology. So I'm going to highlight just, a couple of examples so that we can move. But, there are some technologies that we know will have to be used. And when we are talking, for instance, carbon dioxide removal, CDR, CDR is included in all the emission pathways that IPCC has put together to limit global warming to 1.5. What is carbon dioxide removal? It's a set of different options ranging from afforestation, reforestation, bioenergy with carbon carbon capture and storage. You are talking about ocean fertilization. You are talking about recovery of degraded land. So you're talking about a suite of elements. So that should be good enough. You could ask me, Martin, well, but everybody knows about reforestation, afforestation, so what is new? The thing is that when IPCC is doing this assessment, it gives some confidence that that can work, but not everywhere, and not necessarily when you move the scale. So it might be okay if you're implementing that in short scale, but might not work well or might compromise sustainable development goals if you go in a different scale. So the important thing is other technologies that are in the report of the IPCC might not be mitigation, but it's out there, for instance, to cope with the risks of impacts of climate change. I'm going to give an example, if you don't mind. Solar radiation modification, which is something that is starting to be, researched by some groups. Now, I'm going to write to the point, lessons learned. From my point of view, and coming from the global south, as we call it, we see that there are more opportunities for the development of research in the global north. And when you do these researches in a selected group of researchers and not with a global engagement, where I see diplomacy coming into this, the diplomacy helping to communicate what is happening, and in a way that puts all the countries in the same footing, so with the same understanding. And because there are risks that are not equally distributed. There are benefits, obviously, otherwise they would not be there. But technologies may also have implications and risks that are not distributed equally around the world. So the engagement, what I call the need for an international governance on some of these issues, and that's when diplomacy comes into play, would allow this better understanding of where we are, where we can be, and what are the potential implications. So these are some of the lessons I think we learned with these innovative technologies that starts, being researched in different parts of the world, but not engaging everybody.
Thank you very much, Thelma, to have set the scene and with the lessons you have learned from engagement in the IPCC. But this gives me a good opportunity to hand the floor over to you, Wendy. I think we mentioned CDR, carbon reduction technologies. I think you are working on new materials at the frontier of knowledge today. And we heard as well from Thelma the difficulty to scale those developments, but also to have a real-world testing of those technologies or those of those work within the laboratories. So you are also working with us since 2 years, I think, from the science anticipation and then through this science and diplomacy task force that we have set together in the framework of the materials. In your field precisely, what do you see we can anticipate and what would be needed so that you can accelerate solutions? Wendy, the floor is yours.
Thanks, Martin. Can you guys hear me okay? There's a little bit of a background noise here. Yeah?
Can you, excuse me, Wendy, can you make the sound a bit louder, please? I think we cannot hear Wendy well. Yeah, can you try again? Wendy?
This is all I have. Can you hear me okay? So now, Martin, I can't hear you.
This is good like this. Perfect. Up to you,
Good.
Wendy.
Okay, great. Well, thanks for the invitation to join the panel today. So in terms of anticipation, with regard to the areas that I'm working, I think that we can anticipate some large developments related to carbon capture, removal, and conversion technologies. Just to give you some examples, for instance, I think in the future we're going to be combining green hydrogen with renewable energy, for instance, to convert CO2 into value-added chemicals and fuels. The development of such processes, of course, is extremely important because currently we're using fossil fuels to provide a large number of chemicals, for instance, from the pharmaceutical industry and things like that. In addition to these conversion processes, we can also anticipate in the not so distant future the development of new technologies really related to the direct capture of CO2, for instance, from the air. So the extraction of CO2 is extremely important because it's basically going to allow us to get to these difficult to abate emissions and essentially reach net zero, or even begin thinking about being able to reach negative emissions, for instance. Now, while these direct capture technologies, from my personal perspective, are working, they still lack quite a lot of efficiency and they're still extremely too expensive. So I think in the next few years, we're going to see a huge push, for instance, from scientists and engineers to begin developing new materials and processes that can reduce the energy costs and the economic costs of the capture process. So basically, with regard to what is needed in my area to accelerate the scaling and deployment of solutions, please keep in mind that my work is really centered at the beginning of the technology development process. So we're designing materials basically for their implementation into technologies like direct air capture. So we naturally have a very long path to the implementation part. Okay, so with this implementation, there are a huge number of hurdles that we encounter. First of all, from a materials perspective, if you look at labs around the world, we're all testing materials, really their performance in different ways. Second, when we do tests in a lab, oftentimes this is done in an extremely controlled environment. You can imagine that that environment could look very different in the real world application. So we can't really know how our materials will perform when implemented, and we can't predict things always like their long-term stability. So in my mind, a decarbonization accelerator could help basically via collaborations, of course, with industry to define how laboratories can begin testing materials and even help us develop benchmarks that can really define how materials should perform to really be considered then for the next stage, so the next development stage, right? In addition to these things, another hurdle that we encounter oftentimes is getting those materials to the next stage, so implementing them into demonstrators and pilot testing. Just to let you know, for the last 2.5 years, I've been trying to bring in funding to build a demonstrator just for my lab so that we can kind of compare the performance of different materials under application relevant conditions. This process has been slow and very expensive, and you can imagine most labs around the world don't have access to such tools. So I can see a decarbonization accelerator kind of helping to provide these types of tools so that we can begin to really advance our technology readiness level in the research lab, so to speak, to kind of accelerate the process to market. Of course, this requires very close collaborations with industry to know how we should test these materials. I would say another important hurdle is that everybody needs to realize that we work on extremely small scales. But in the end, this technology, if it's implemented widespread, it's going to have to be implemented likely on the ton scale and relatively quickly. And while as scientists we try to keep costs in mind, it's not always so easy to predict how much it's going to cost when produced on the ton scale, or importantly, the environmental impact of that process. For instance, we might be using precious resources to produce those technologies, and we don't know what type of impact it will have on the places, for instance, where we recover those the resources from. I believe a decarbonization accelerator can help provide the tools necessary so that we can do early assessments of materials or devices to understand basically how to assess their environmental footprint and their techno-economic assessments, do those up front so that we know what it'll look like when we scale, for instance, to the ton scale. I think this could be very important for acceleration. Last but certainly not least, the overall process for materials development is just in general extremely slow. It can take us years to basically get to a new material that we're ready to kind of implement into a demonstrator. So imagine if a decarbonization accelerator could also provide links to computational tools that could, for instance, predict the structure and performance of materials before they're actually made in the laboratory. You can imagine such tools could provide us with materials to target that'll be top performers and that are not, for instance, made from critical resources. But of course, for this sort of thing to happen, we also need to begin to develop standards on how data is formatted and how it's shared so that computational tools can take that data, mine that data, and make these accurate predictions. So I think in general, really, a decarbonization accelerator, everything that I've listed basically today as hurdles, in order to overcome those, we have to basically bring together a huge number of different players. And this can be players from industry, players from academia. Also, if we want to implement these technologies on large scales, we need diplomacy and policy, we need economists. And I think an accelerator requires bringing all of these individuals together.
Thank you, Wendy, for your statements. I have picked a couple of things for the decarbonization accelerator: the problem of scales, the problem of lacking benchmarks, lacking standards, the slow pace of research in the lab, and the need to accelerate that by bringing the different actors together from industry, from academia, but also from the regulatory side of it, so that we can also have the way for real-world testing, prototyping, and demonstrating the potential of those technologies. Now, Alex, if I go back to you, I think we heard from the IPCC at the nexus between science and policy. We see the situation in the labs about the potential of those technologies, but also the roadblocks that you've seen. Where you see the role for science diplomacy with this anticipatory outlook that we are proponing at GESDA?
Yes, thank you, Martin. Possibly we should start by trying to dissolve an apparent contradiction or say an counterintuitive argument in our discourse here around GESDA. On the one hand, we have the urgency of the challenges, generally speaking, and certainly as far as climate change is concerned. So urgency of challenges and urgency of action needed. And then on the other hand, we speak about science anticipation, scrutinizing the horizon and trying to understand what is happening in the lab and where the scientific breakthroughs may well come from in 5, 10, 25 years, and what that will have as an impact on us and how we will be able to use those breakthroughs. So there is some contradiction there in the sense that surely the time is now for our diplomatic resolve and action, and not in 25 years or so. So multilateralism certainly badly needs speeding up. And yet, there can be, in my opinion, no acceleration of diplomatic work and of coming together of the nations of this world without anticipation of things to come, science and technology-wise. And that's for two reasons. As I say, we must accelerate the diplomatic response to the opportunities and the challenges that are brought about by science and technology. But we can only do that if we see them coming, if we understand their potential impact for good and ill, and if we anticipate them. That's the word. So there is no acceleration of diplomatic processes in the face of existing problems that have already developed their impact and are already hitting us. Once the challenge is there, then the opportunity is gone somehow. Then we can only run after the problem without any real perspective of solving them, and we all have this collective feeling of being overwhelmed. And second, the difficulty is that we cannot, as an international community, go straight from anticipating breakthroughs, scientific and technological breakthroughs. We cannot go directly from that towards negotiating sustainable solutions. Because whenever we find ourselves in formal negotiating processes, then we revert to what we're doing as diplomats, that is maximizing our national positions, and so we are not negotiating in a sense, or we're not negotiating for the humanity. We're not maximizing or building the common ground. And so the common denominator will usually remain inadequately low. So that's why we need an instrument like the one GESDA is offering as an honest broker that offers an environment in which we can come together inclusively in order to learn about the mid-term, long-term anticipation of opportunities and challenges that comes through science and technology. And we can do that in an equitable and inclusive manner. And that certainly talks to what Professor Krug asked, that we need to make sure that there is a joint and shared and common understanding of the challenges and the opportunities. And so by coming together and understanding the impact, we can then start working together on solutions. We can mature them, we can ferment them, and like with the decarbonization accelerator Wendy was referring to, but we do that outside of the formal negotiating processes. And so we can mature them and bring them to a level where then the legitimate actors of global governance, once a sufficient degree of maturity has been reached, can repatriate the draft solutions into the formal settings of the United Nations and other international organizations. But then we will be able to proceed from a far higher degree of commonality, of nuance, and of sophistication as would be otherwise possible. So I think that is where the acceleration lies, through the detour of anticipation, and that is what we like to call anticipatory science diplomacy, and try to offer to all the international, to all the actors of international governance through GESDA.
Thank you, Alexandre, for this. A couple of statements that I took from your inputs. There is no diplomatic accelerations without the capacity to anticipate, the science and technology that's being worked on in the lab and its impact. This is how we can balance the urgency to act now with the necessity to anticipate what's on the horizon in science at 5, 10, 25 years. I think those are a couple of takeaways that I've taken. I have others, but I will come back to this in our discussions. Massamba, I've seen that you have been taking notes during the different input statements. I would like now to give the floor to you. How does this concept of anticipatory science and diplomacy, the acceleration of diplomacy, link to the work of the Global Innovation Hubs, where you try to be a conduct to innovation and to solutions that can be, implemented on the ground?
Thank you, Martin. Very pleased to be part of this very important panel. Yes, there is always a challenge when you are telling people we need to act now, but we need to take into account the longer term horizon, and this is precisely what needs to be done. So the Global Innovation Hub was launched at COP26 with two objectives. We wanted to enhance the effectiveness of innovation when it is used to support climate and sustainability. And also we wanted to contribute in enhancing the use for innovation to serve people and planet. So to do so, the very first thing that needs to be done is to have a climate and sustainability innovation goal. We have the SDGs, we have the climate goal, but we have not yet translated this high-level goal into innovation goal. We will need to start from the needs, this goal, and then have backcasting normative scenarios that translate them into a need for innovation, so that those that are working in developing the solution can have a clear signal. The second aspect is that we do not have a clear demand for climate and sustainability solution. And this is because we lack a moonshot mindset. And this leads to a situation where the development of climate and sustainability solution on the one hand, and bold ambition in the other end, are locked in a vicious circle where each of the two is at the same time cause and consequence of the other one. If you ask those that are setting target and goal why there cannot be more bold, they will say because we do not have the solution and we want to be credible. If I set a goal and a target and I'm not able to articulate how I will achieve this goal and this target, I will not appear as credible. So if the solutions are not in place, I will not be able to take more ambitious target because I want to be credible. But the problem is, if you go at the side of those that are developing solutions and you explore why they are not producing at the pace and at the scale that is required, the climate and sustainability solution, they will respond because there is no demand for such type of climate and sustainability solution. So there was a need to break this vicious circle in which these two concepts are stuck. The second aspect is that when we talk about innovation, the tendency is to think innovation at the sectoral level. This is definitely needed, but this is not enough to achieve the long-term goal of the Paris Agreement as well as the SDGs. Because we need more transformative type of innovation. We need to go beyond the incremental innovation that take place at the sectoral level. So it means that we need to expand the space of innovation, which is currently very narrow, and encompass new type of innovative solution that cannot appear if you focus only at the sectoral level. Just to give an example to illustrate what I have just said, of course, moving from combustion car to electric vehicle is something good, and this needs to be done. We need to continue to innovate so that we can have electric vehicle at costs that are the lowest possible. But why do we need car at the first place? So moving from combustion car to electric vehicle is good, but having less car is much better. So what we are saying is innovation need to be used at the sectoral level for this incremental change, but it has also to be used for more transformative change that are challenging actually the need. If you ask the question, why do we need cars? The response will be, we need car for mobility. Then the next question is, why don't we use innovation to address the need for mobility, but with less car? Why don't we use innovation to design our city differently so that they are more compact, so that they are more complete, and the product and services that are needed are all available at walking and biking distance. We can even go one step beyond, because mobility is not a core need. Mobility is a means, a very important means, but it's not a core ultimate need. The need behind mobility is access. Why don't we leverage innovation so that we can access products and services with less need for mobility? I'm not saying that we should not be mobile, but it should not be a constraint. We need to be mobile if we want, but it should not be a constraint to have access to product and services. The third element is that When we are saying innovation, generally we focus on technology innovation. Technology innovation is important, but alone it will not help address the global challenge that we are facing. We need to have a more integrated approach where technology innovation will be combined with innovative financial instrument, innovative policy instrument, innovative business model, but also social innovation and innovative cooperative approach. Because as it was mentioned by the professor, collaboration will be critical. We cannot achieve the long-term goal of the Paris Agreement and the SDGs if we do not put in place radical collaboration. We need to learn, we need to have what I would call societal learning, that is the in-depth collaboration that can reinvent new pattern of working together.
Thank you, Massamba. We have a lack of moonshot mindsets, and I will come back to that afterwards. But I also have seen Thelma writing quite some notes when we discussed previously, when we discussed about the space needed for diplomacy acceleration and the space given by this science anticipation, by the fact that we look at what's happening in the labs, and that we provide the diplomats also with the tool, to act. I think, Alexandre, you said to maximize the benefits for humanity and not only maximize the benefits for your own country. You have 20 years of IPCC experience. Sorry to come with the 20 years again, but what are your reactions about the different statements that you have seen, but also in particular, the balance between anticipation and diplomacy acceleration?
Thanks, Martin. And here in others, I think that I would like to split the discussion into two. So when we talk about limiting global warming to 1.5 degrees Celsius, IPCC has been very clear from the beginning. The science tells us that we have to do system transformations, right? So we are not talking about transitions, it's transformations. Transformations means that you have to really speed up. We have to be ambitious. We have to reduce emissions. We have to enhance the sinks. So you have a huge responsibility. The more you do now, the less you're going to have to rely on other means that might bring additional risks. Okay? So that's one aspect of it. So when we're talking about energy system transformation, we are talking about decarbonization as one of the elements, but we are also talking about transformations in land, in agriculture, in forest, in industry. There's going to be a challenge for the industry. So that's one aspect of it. The second aspect that I want to single out is the one that is not linked to mitigation per se, but other aspects of the research that is going on technologies that might minimize the potential impacts of climate change. For instance, the increase in the hot days or extreme events. So it's not mitigating, but it is minimizing potential impacts of climate change or the increase of the global temperature. So I think that I focused a lot on the second part of my talk. Martin, I think that COVID should have taught us some languages. We are not prepared to it. We didn't anticipate the need for research or development or even being ready to cope with something because we didn't know anything about it. We didn't know about how to cope with a global issue. And I might say to you, it might not be the last one, right? So we're expecting others to come. I hope that governments and everybody's going to be better prepared for that. But so when my notes, anticipatory, what is the fear that some countries have when we talk about anticipatory technologies to not to mitigate but to prevent or minimize risks? The issue is that when you're studying that, it might be seen as an accommodation of governments not to do enough now because something else is coming. So what is called the moral hazard, that it's a big fear that governments have as a whole. So let's wait for that. We are going to have technologies to alleviate. So that's one potential issue. So to finalize my presentation is communication, engagement is all that we need from diplomacy. The IPCC, to me, is the bridge between science and policy because governments are included into the review process. They are included in the approval of the summary for policymakers. They know what's going on. So when they know, they need to take actions, right? So what is expected that in a multilateral setting like this, the diplomats will do the best to work in a collective way to avoid any harm to countries to save their own. So this is a collected effort. So I hope this helps a little bit. And so I am in favor of anticipatory research, despite that you don't know exactly what you're anticipating, but you need to be prepared for that. High risk for research, I would say, in that fact. Yeah.
Thank you, Thelma. This gives me two questions, one for Wendy and one for Alexandre. For Wendy, around this idea of speeding up acceleration and the fact that you don't really know what science and technology might be able to bring in 10 to 25 years. So how do you combine both? And then, Alexandre, to you, I will give the questions of the moral hazard. Is just by anticipating technology of the future, delaying or giving an excuse to governments not to tackle the climate issue seriously? But first to you, Wendy.
Sorry, Mark. Can you repeat the question?
The question to you was about the need to speeding up and accelerate, having these moonshot ideas, and maybe also about the potential of your technologies that you're working on. And then the other question that I had for you is if you anticipate where your technology will go, how you deal with the uncertainties beyond this inevitable anticipation.
Well, to address the last part, I'm not sure how you deal with the uncertainties. I mean, this is a really difficult question to answer. However, in terms of the technologies, I can tell you kind of what we anticipate with regard to, for instance, what's to come. Of course, it's focused, on specific technologies related to decarbonization, and we're always trying to think about what's on the 5-year, the 10-year, or the 25-year horizon, so to speak. And I think within the 5 years, I expect to see kind of incremental advances made. For instance, well, I don't know if one actually would consider this very incremental. I guess that's based on a personal perspective. But for instance, we might expect things like with NETs, for instance, like direct air capture, which I've already mentioned, we would expect that these are hopefully going to approach capture costs of around $100 per ton of CO2 removed from the atmosphere. I think something like this is important because it begins to make us think about the possible development of things like a CO2 market, for instance. I also expect in the next 5 years the improvement of efficiencies of other technologies, for instance, related to decarbonization. This could be batteries and photovoltaics, right? Basically, these things combined with a reduction in device costs, maybe we're going to move more towards utility scale, for instance, solar PV. Also on the 10-year horizon, now I liked what was said earlier about basically getting away from incremental advances. And I think with regard to what we're doing, in particular for materials development and process development, one important thing that's going to take us to these moonshot kind of ideas that you're describing is really the development of high-powered computing resources. And I think that these are going to get us to allow us to discover new advanced materials relatively quickly. And effectively, as a chemist, these computational resources could predict a material. Then we go into the lab and we make that material. And you can imagine just giving us targets could really help us accelerate the discovery of materials and, of course, their implementation, because I told you it's a very slow process during the actual development. We can imagine that with this will improve other technologies like converting CO2, for instance, into value-added chemicals and fuels. Of course, in the 25-year horizon, I'm hoping to actually see that we're going to see effectively kind of computational resources are going to change things so that we even have potentially machine-run laboratories that are responsible for designing, making, assessing, scaling, and even maybe manufacturing materials that are required for decarbonization-based technologies. Did that at least help answer part of your question? Oh, I can't hear you again.
Thank you, Wendy. My sound was out for a moment.
Okay.
Yeah, this responded to my questions, and I think 25 years agenda is quite a long time. But I think it's important that we keep this in our head, and don't forget about the potentialities of these 25 years technologies give us to respond to the challenge of decarbonization. Now up to you, Alexandre, the moral hazard question. I think this is a question that we often hear when we think about climate change and decarbonization, and where we try to act in anticipation. What's your take on that?
Thank you, Martin. Well, I think that the solutions, the innovative solutions that are of a transformatory nature and that are systemic are so huge, so complicated, and not readily actionable, because a lot of work still has to go into them, so that waiting for them to somehow miraculously emerge is irresponsible. So yes, it is a real moral hazard, and countries should not be tempted by it because it is irresponsible. And when Thelma explains to us that we need to bring the science into the diplomatic debate, how it's been done very successfully with the IPCC, so as the policymakers understand the science that is behind the challenges they must govern, then that is, I fully agree, and it brings back an insight from a totally different domain of my diplomatic activity, that is preventive diplomacy, genocide and mass atrocity prevention, conflict prevention, and so on. What we learn there is that usually it's not the early warning the problem. One sees things coming. It's the early action. Who then feels responsible to act based on something one has seen coming or should have seen coming? And that is what GESDA also tries to offer. It is not only a think tank that does the anticipation of science breakthroughs and offers them for discussion. It's also a do tank in the sense that it curates conversations, inclusive conversations of policymakers, diplomats, scientists, technologists, civil society, private sector and philanthropy to come together and to develop, prototype, think of solutions that could be brought to scale, just as Wendy explained. And they do it in a manner which also responds to some of the questions or the needs Massamba was raising, in the sense that we need to go beyond a mere innovation or a sectorial level. We need to be to expand that space. That brings me back to what Wendy said at the very beginning, that she hopes that by bringing in computational power into her chemistry, that will accelerate the development of new materials that are at the very beginning. So we need to anticipate, but then based on this early anticipation, start working. And this we can only do in some sort of safe environment, as GESDA is offering. This we cannot do in formal processes, as our conference of the state parties to conventions. So that's where this anticipatory science diplomacy, as implemented by the Geneva Science and Diplomacy Anticipator, comes in support to enrich the debate of the international community.
Thank you, Alexandre. Early anticipation for early action, positive irresponsibility, and many other interesting comments that you make. I think we slowly arrive at the end of the session, but I still would like to give the possibility to the public to comment or to question if there is a need, a will. Yeah, there's a question over there.
Yeah, one quick question. So around 20 years ago, I shifted my career from oceanographic research to carbon finance. And over the past 20 years, have seen a lot of innovation in the ocean as a potential carbon sink, some engineered and kind of cultivation solutions. But I guess what I'm curious about, both from a scientific perspective and a finance perspective, permanence is an important factor. And I guess from the IPCC's perspective, how does permanence factor into the work that you do? You know, whether it's related to ocean or nature-based solutions, where does permanence play a role in the research and the projections and so on?
Well, I'm going to respond very quickly to your question. It's obviously that permanence is a big issue. So when we're talking about nature-based solutions, and I refer more in terms of let's say, forests, right? So forests are extremely vulnerable to climate change. They are vulnerable also to the extreme events that are happening in terms of droughts, floods, and hot days, and the compound events that IPCC is now talking about when you have more than one of these extreme events happening. So my quick response to you is that these things, you know, when you look about nature-based solutions that are based on nature, they only will work if you do a lot in terms of reducing, you know, the big source, addressing the big source of the problem, which are the fossil fuels. There is no other way of doing that, because it will end up being more of a problem than a solution per se. So if they work together, the solutions, you know, from the fossil fuel side and the nature, I think it has a hope. But besides that, it's complicated.
Thank you, Thelma. I think we slowly get to a closing of this session. Before giving the final word to you, Massamba, I would like to thank very much our panelists, both on screen and on stage. It has been a pleasure and a privilege to have you during this hour, so thank you very much. As Massamba said, I think we have been very happy to be involved with the UN Climate Change Global Innovation Hub to set this session today, and we look very much forward to continue the collaboration and discussion further between GESDA and your organization. Massamba, maybe I can give you the final word before we close, and wishing you an excellent continuation of the conference.
Yeah, so there are very important takeaways we can get out of this discussion. We need to act now is one of them. That's very important. And science anticipation facilitate action now. And for us to be able to contribute to the development and upscale deployment of technology, we need to both pull and push. We need to push with science anticipation, and we need to pull by identifying and formulating a demand for climate and sustainability solution. So thank you again to all of you for your contribution, and it was a very important moment for us, the Global Innovation Hub, and we're very pleased to host this session. Thank you.